All right, we're ready to start. This is Anders Olson, and David I is next to me in the studio.
I'm back in Scotts Valley last Friday. Thank you, Anders and Al, for taking care of the session last Friday. I was on a plane back from London, so I was in the air and no internet access. Al is busy today, so it's Anders and me.
You weren't on Wi-Fi on the plane. We were trying to send you push notifications last Friday.
British Airways, the 747 coming back doesn't have Wi-Fi. Yet.
There you go.
Yet.
So what's true native, and why does true native matter, David?
Well, for me, it's always been about either assembly language on mini computers or using compilers, generating optimized native code. And so I think in the world of our multi-devices today, having native optimized machine code, giving you full access to the underlying operating system and hardware, and having that native look and feel on each device.
There you go.
And you can join in the conversation. I better turn on my iPad for Twitter. You can post tweets, use the hashtag EMBTDD. You can also follow at EMBTD Direct if you want to take part of the conversation, not only today, but all along the way with Developer Direct. You can also send email if you have questions during or after. We have a global set of software consultants, evangelists, and employees that are following an email address, developerdirect.online@embarcadero.com. If you have product questions, sales questions, technical questions, want to give us feedback on Developer Direct, things you'd like to see in the future, just send an email to developerdirect.online@embarcadero.com. And again, you can follow the conversation on Twitter with hashtag EMBTDD. This is the schedule that we're using in this Q2 of Developer Direct here in US and Canada. Today is May 10th. What's true native and why does true native matter? Just a reminder to all you developers that are online that Sunday is Mother's Day, May 12th, at least here in the US. I'm not sure about Canada. Maybe somebody will tweet. Maybe it's US and Canada. I know Mother's Day is different day in the UK, for example. So don't forget when you're programming and maybe heads down staring at your screen that Sunday, say hi to mom. And then the rest of the schedule. So today we're going to, as always in Developer Direct, we'll cover some news and then we'll talk a little about the topic, which is true native. And then we'll do a bunch of demos and then take Q&A, all along the way and at the end. And then move on to next week. So let's take a look at the news. Okay, just a reminder, if you haven't heard about it, RAD Studio, Delphi, and C++ Builder Xe4 are released. All new release updates to the runtime library, a completely revamped FireMonkey for iOS. Some developers were thinking that maybe it was just the same FireMonkey that we shipped in Xe2, which was based on the free Pascal compiler. This is our own native compiler. We'll talk about that today. It's completely updated, third generation of FireMonkey, lots of runtime library, lots of things that you get if you're only doing Windows. You get all the benefits of FireMonkey updates and enhancements and new capabilities. For VCL developers, you get all the runtime library updates. You get all the low-level frameworks for sensor and device management. All of that is available to you, whether you're doing VCL only on Windows or FireMonkey only on Windows or FireMonkey on multi-device for both Delphi and C++. If you don't have Xe4, you can use the trial download. There's two ways. There's the traditional download, which grabs an executable and then pulls the rest of it. There's also the instant trial, which uses our AppWave technology. So you can start up I created a video that shows how fast you can. I think the splash screen comes up in about 10 minutes as the instant trial is streaming the IDE down to your machine. About 11 minutes, you can create your first either VCL or FireMonkey application. And I think it was another 5 minutes after that, about 15 minutes, you're building your first iOS application, all while the rest of the offline caching of the rest of the capabilities of the IDE are being brought down.
And then if you use Mac and Cloud, if you don't have a Mac, you can run the simulator and test stuff on Mac and Cloud, and their starting rates are $1 an hour. And the instant trial, I just want to add, is really, really cool because like David said, it takes 10 to 15 minutes in most cases to be up and running, as opposed to downloading multiple gigabytes, which takes who knows how long on your internet connection, and then installing it, which takes another half hour to an hour, depending on your hardware. So the instant trial is definitely the way to go if you want to do it quickly.
Yep. So get started, or if you have XE4, then we're going to show you through these different developer directs all the things you can do on Delphi and C++ for both Windows, Mac, for C++ and Delphi, and then for iOS right now for Delphi, and then for you C++ developers, iOS is coming, and for both Delphi and C++, Android is being developed, and just stay tuned. Get your upgrade subscriptions, so you'll get all the updates and all the upgrades that happen over the next 12 months. There's going to be a lot of exciting stuff. Of course, we have, if you're into the Mac, you've got Apple's Worldwide Developer Conference coming up in early June in San Francisco. Speculation about iOS 7, about OS 11, OS XI.
There you go. New devices, maybe? Who knows?
Yeah, maybe new devices and hardware. And Google, Android, Google I/O, developer stuff is happening. So lots of changes, and we're on top of all of it. We've got developers focused on making sure we stay up to date on anything that happens in the operating systems we support and the devices that we support as well. Just want to remind you, there's a webinar coming up on May 22nd, so week after next, on-device rapid prototyping. That'll happen at 3 time zones, 6 a.m., 11 a.m., and 5 p.m. Pacific Daylight Time. That'll be followed that Friday by a Developer Direct topic on the same thing, on-device rapid prototyping. We're going to go through how quickly you can build user interfaces, working with your users to make sure it's the right thing. You can prototype your data by using the prototype bind source, and then when you actually have a database, maybe it's not done yet, you'll be able to move there. So, and then quickly switch from using a prototype bind source. And it harkens back to the Delphi 1 ad that I blogged on the launch day for XE4, which was from prototype to, at that time, .exe with Delphi 1. It was the first Delphi 1 ad. You can do much, much more in building your prototype and going from prototype to application to deployed on multi-device systems. So join us one of those 3 times on May 22nd. And also, we've talked about this a little bit and shown a little bit of it, but last week we put out was it last week or this week? We put out a press release about the introduction of InterBase to go and InterBase Lite, embedded SQL database for iOS, IB Lite and IB to go. And this chart just gives you a little bit of information about what you can do. So IB Lite is the free version of InterBase that you can embed inside, statically link, embed inside of your application for iOS. SQLite is also there in the operating system. It has some simple capabilities, I think 4 data types and such. If you want all the ANSI SQL 92 data types, you can use InterBase Lite, and again, it's free deployment in your applications. If you need security, encryption, if you're going to put a database on a device, that device might go walking because they have little legs, right, Anders?
They do.
They walk, yeah. It's that new feature. You hit the special key. So if you want to put a database on the device and you want to encrypt it, then you can get a license for InterBase to go. And InterBase to go has full capabilities for encryption and transactions and full sets of transactions and so on. So the great thing is it's the same programming model, the same database access, whether it's through FireDAC or InterBase Express or DB Express, whether you're working with IB Lite or InterBase to go on iOS. And then we have InterBase to go also as a DLL and dylib on Windows and Mac. So, and I should have said on the SQLite that there's no DLL or dylib in a sense for SQLite on iOS. It probably is a dylib, I guess, sitting in the operating system for the iOS. And Anders, I think the reason for all this is there's a restriction.
Yeah, Apple, of course, being the owner of iOS and the operating system, they're all dylibs and they're loaded dynamically. In fact, when we start talking about wrapping APIs that we don't wrap, we'll talk about that a little bit later today, is if you want to load a framework that we're not loading, then one of the first things that you do is actually load library on the framework dylib. And you can see that all over our FireMonkey source code in the iOS.pass files.
Yep. So So you can use SQLite. We have DB Express and FireDAC support for SQLite on Windows, Mac, and iOS. And now we have InterBase running on Windows, Mac, iOS, Solaris, Linux. I think those are the platforms. And I forget which flavor of Unix. There's a couple flavors of Unix as well. Okay. There's 2 documents now specific to XE4 on the white papers and articles page on Embarcadero.com. There's the RAD Studio XE4 Product Reviewers Guide. So if you want to read and get started on what's new in the product, then you can download that white paper. You can also, if you want to see the language changes, and Marco talked about those in the product launch a couple weeks ago, the April 24th product launch. There's a white paper on the Delphi language for mobile development and some changes in the language there. So you can go and get those from the resources, white papers, application development. It's all there for you to download.
All right, I just answered a question here with an installation problem. Well, I've seen that particular problem in the past, but I recommend that Grigore log a install case. It's a free service that we provide for installation, and they can get it resolved for you.
Okay, and that URL for Mac in Cloud is simply www.macincloud.com.
Yes.
I'm going to put that in Twitter because that's one of the things that we do here. So if I can hit copy. Okay, let's do this. All right. And then there's lots of other live events and upcoming webinars. There's a C++ webinar coming up in early June. That we're going to do on the tool chain and compiling for multi-platform for 32-bit, 64-bit at Macintosh and using the languages and the capabilities of the different tools. So stay tuned for that. And there's lots of live events happening as well all over the world. So you can check all of those. Go to embarcadero.com/news/events. And let me put this Mac in Cloud, paste that in there and make sure we have the tag. And okay, on Twitter now, there's the Mac in Cloud link. So if you go to Twitter and search for pound over here, hash over in Europe, I guess, EMBTDD, you should see that link. So today it's all about True Native and why it matters. We're going to show you lots of examples. So let's get started and go through the slides and get to the demos really fast. Okay, so we have lots of compilers in RAD Studio XE4. If you have RAD Studio XE4, you get 8 compilers. So that's a good deal right away. 8 compilers for professional, for enterprise, architect, ultimate, and so on. And if you have Delphi, then you get 5 compilers. If you have just C++ Builder, you get 3 compilers. So it's a lot of compilers. For C++, we have our Windows 32 and Macintosh OS 10 compilers, BCC 32 and BCC OX are the names of the compilers. And then we have our 64-bit compiler, BCC 64. BCC 64 uses a different architecture. It uses the LLVM backend to do optimization and code emitting. And we're going to use that architecture for the future to get to ARM chips. And it turns out that the Delphi compiler, one of the 5, we have a Delphi 32-bit compiler in Windows, Delphi 64-bit compiler, Delphi Macintosh, Intel compiler for OS 10, and we have a Delphi Macintosh Intel, Delphi iOS Simulator Intel compiler, DCC iOS Sim, and then we have the Delphi iOS ARM compiler. The Delphi ARM compiler also uses the same architecture, the LLVM compiler tool infrastructure to generate ARM code. So eventually, when we get ARM support for C++, again, it will use the same infrastructure for tooling, the LLVM infrastructure. So we go from Delphi source code in the IDE. If you look at the binaries, you'll see that Delphi compilers for iOS Simulator and iOS ARM as executables for command line tools, and then those are baked into the IDE as well. So we go right from Delphi source code right to native code for the ARM processor. Other systems, for example, if you use script languages, they'll use some kind of runtime, WebKit and other things and maybe some other wrappers around it to get to the chip. And if you're using things like Java bytecode, then you go through some virtual machine, which gets you the chip. So from a development standpoint, one of the things that I've always loved, including my right out of college early days of real-time computing and real-time assembly language programming, I was right to the hardware, right to what we called an operating system, but that was almost nothing, right to the hard disk controllers, all that stuff, right to the hardware and right to the operating system. And Anders in a minute is going to show you some examples where he goes to the operating system, and I'll show you something where we go right to the GPU using FireMonkey image effects, for example. And what that ultimately gives you is when you hit a button, when you do a gesture swipe, whatever it is that you're doing on the device, whether it's on touch screen Windows, a touchpad Macintosh, or on a device, you make the operation and you're there. It responds quickly. So low latency equals great user experience. Now, a browser where you're inside of Chrome or IE or Firefox or Opera or Safari or whatever it might be, it's a little more expected that if you click on something, then it goes back to the server. It takes a little while. Something does its thing. It comes back, runs some JavaScript code. Maybe you're using Ajax to speed up what's going on. Maybe you're doing callbacks of some kind using some other libraries. But ultimately, what's between you and the operating system in things like HTML5 and JavaScript is going to be some kind of runtime or some kind of add-on inside of the browser itself or inside of the operating system. So it's accepted that you sort of click and you wait a little bit and come back. If you look at apps on these devices like tablets and on Android, you can tell which apps are browser-based, whether they're a browser container or you're just using the browser. You kind of click and get to Facebook, click and do something. But then you go and look at native code apps that are running on Android or iOS. For example, Amazon Shopping app or eBay bidding app that are built in native code. And there's some quotes that we have. They're not included here, but Facebook tried using the browser and tried using JavaScript and HTML5, but for a highly interactive, highly performant system, it just didn't work as well as they wanted. It didn't perform as well. So they rewrote everything in native code and are continuing to implement more capabilities as well. So in apps, nobody wants to click and wait. Now, it could be architecturally or because of business logic or because of some network, or maybe you have a long-running query happening on a server somewhere, on a business object running on a server somewhere, that it takes time. But in general, in an app, you want to click and have it do something. You just want that instantaneous response. In fact, who doesn't want instantaneous response? Whether you have to do some of it with architectural capabilities, caching, whatever it might be, local data, that's cached, so you don't have to keep going back through the network to the server, especially if you're running on some slower network system. So again, low latency is great, high latency is awful. And we want access to everything. We're developers, right? We don't want anything between us. Okay, fine. Maybe there's a function you're calling. Maybe there's some runtime library. But usually that is a wrapper or a layer, a component interface to the operating system. So we want to get right to it, and we want to be able to get to the operating system and get to the hardware when we need to. Also, native has come to mean separate from native code, separate from high performance, highly optimized machine code, is making sure that it looks native, that it looks either the way that the device is supposed to look, or that you can have your own support. You might have your own look. So styling, either native or custom, we provide in the case of Delphi for iOS, and will provide for C++ for iOS and Android. So list boxes with curves around them to combine the list box entries into one. Being able to do bitmaps and other things, being able to do your own custom style if that's what you want. When I was last week, not here, I was in Denmark for 2 days in a workshop teaching people, some Delphi developers programming, multi-tier, iOS, multi-device, and so on. There were several developers. They said, look, we build applications that connect to audio, high-end audio equipment for TV production, for sound studios, and so on. And all of our boxes, whether it's Marantz amplifiers or mixers, they're all like black. So we want a dark style, because then the pad that's going to sit there stuck on the device or sitting on the desktop matches everything else in the room. The LED colors, the sliders, the background, everything is dark. And so they wanted a dark style. And I said, no problem, you can have dark style if you want. And there's an example of it on the right. Also, Native can mean using the native controls that are available on each of the platforms. On Windows, we've always had access to the common controls or some of the custom controls that Microsoft provides for us. Same on the Macintosh, same on iOS. You want the right kind of icons. You want that look. You want the choice of the layout of your application, both on an iPhone and on an iPad. You want it to look right on each of the different multi-device platforms that you're on. You can do that with styles and style lookup. You want to use native iOS controls. And if there isn't a component wrapper, then you want to get access to the operating system that has those controls so that you can use them. So in the case of Delphi for iOS, if you use the T-Calendar edit component, we'll see that in action. Underneath, we'll use the date picker, that nice floating wheel that spins and animates very nicely. If you're going to do a copy-paste operation, you want that pop-up of the copy-paste speed buttons that you can just choose very quickly. If you have a combo box on Windows, you want it to look like a combo box, or maybe you want to customize it in some way. On a Macintosh, that's going to be a custom picker, which rolls again through the choices that are in your combo box. And same for text editing, for for keyboards. On iOS, there's, I forget how many, 7 or 8 different keyboards you can choose, not counting all the foreign language keyboards, depending on where you are. So whether you're putting in numbers or contact information or a URL keyboard and so on. So you want access to all of that, and we provide all of that in FireMonkey. And if there's something else you need to do, you can get to it as well. And you can also add your own little buttons on top, at the top of the keyboard, that you'll see, for example, when you're in a form, next, previous, done. There's some little buttons that can show up above and beyond whatever you have. All of that is available to you in FireMonkey for iOS, and where possible in FireMonkey for Windows and Mac.
For Delphi apps with FireMonkey, when compiling, is a Delphi code being translated to Objective-C? No, it's not.
No, native code.
We are cross-compiling natively on the Windows side, and then it gets delivered over via the PA server to your Mac. Follow-up question, why the need for Xcode? And the need for Xcode is purely legal in the EULA documentation and things like that, requirements from Apple. You're required to have Apple hardware, and you're in fact required to have Xcode's command line tools for code signing and package building as part of your tool chain. So that is why that is required.
Yeah, so you'll see, when I go to the ID with the connection that you set up between your Windows and your Macintosh device, you'll see that we keep track of where all the libraries are. The runtime libraries that have debug information inside of them. In Windows, when Microsoft gives us debug versions of the Windows SDK and DLLs, and they also give us the release versions in addition. Apple doesn't have that capability. That basically, we have to use whatever Apple puts on the operating system and whatever Xcode installs. And I forget which version it was with Xcode. It used to be Xcode had the libraries, the command line tools and libraries were separately installed, and then somewhere along the way, Xcode 3. something, or maybe it was 4.0, they put everything in an application bundle, which meant it was hidden in a sense from most users of using things like GCC or command line tools, other languages.
Xcode became an app somewhere around 4.2 or maybe after, but anyway.
So that's why you have to install the command line tools, which then put them down in user lib and use in the application places. And again, we're not allowed to.
Actually, most of them still get installed in the app bundle, but there are some stuff that gets put in user bin, so you can find them, like Xcode select and Xcode build and all those kind of things.
So to show you, I guess, I'm on there. Okay. Let's just create a file new FireMonkey mobile application first, and then I'll get to some other stuff later. Here's my target platforms iOS simulator that uses the Delphi compiler for Intel and the iOS simulator. Apple does something different than Android. Android gives you an emulator which has a Java VM inside of it and emulates an Android device. What Apple does is the iOS simulator is actually an Intel application that is compiled and linked for Macintosh, and it runs there. It's not a simulator or emulator. It's a full running Intel executable. and then you have the device. So here's the edit connection, for example, for mine. So here, if I look at the device, I just specify the name of my machine, Samwise Gamgee, and then I can go here and look at the SDK, and I'm running iOS 6.1 on my iPad and my iPhone. Wherever that, oh, there's the iPhone 4S, and then here are the paths to all of the different libraries that are available for both Macintosh development and for iPhone. So we're not allowed to ship all of these. Apple doesn't give people an SDK. They simply sit on the Macintosh. So here's all the different parts. And so what we do is we send messages from the IDE over to the Platform Assistant Server, which is running over here on the Macintosh. There it is. And it is sending information back to the IDE to help in the compile and build process, including two command line tools, several command line tools, one to sandbox your application and one to code sign your application so you can send it to the device. And so to show that this is actually native code, we don't cross-compile to another language other than machine code. We don't use Xcode for anything for compiling and linking. It's all done in the IDE, and then we send it over. I'm going to put a button down. And this is the sort of classic first application that we test to make sure everything is working on each device. I'll double-click and say button1.text is equal to 42, right? And we'll save this all and be done. So now we've got, let's see, unit 12 and project 15. All right. And let's first go to the simulator, and we'll run this thing on the simulator. So let's compile and run. And now it's going to compile, deploy this to the Macintosh, and there the simulator, that's the application running. And here's my button, and it says 42. There's a few things the simulator gets you. You can choose what device it is, what version you're testing with. You can do rotate, shake, gesture. Over here in debug, you can set a location. Like I have it set to Apple's headquarters. That's on Infinite Loop over in Cupertino. You can put in a custom location and put in your own longitude and latitude. So if you have a location-based application, you can do that. And then when you're done, come back. Now let's set a breakpoint in here, and let's run with debugging. So when we run with debugging, here it is. Here comes our application again in the simulator. Okay, it takes a little bit more now because it's now setting debug hooks. So the Platform Assistant Server is talking to this process that has been started and also put in debug hooks into it. So when I click the button and I go back to my IDE, it looks like it's hung over there because that IDE is in control. Here it's hit my breakpoint. I can say View Debug Windows, CPU. Let's look at the entire CPU. Those are Intel instructions. So we're going right from the Delphi language to Intel machine code in our compiler and then sending that application over to the Macintosh. Okay, now it's running. So if we go back over here, it responded and set the text caption. All right, let's go back now to the IDE. And this will bring it home, I think, even more. Let's go and debug this on the device. Now, I'm going to make sure my device is here. And we use a utility called Reflector. It used to be Reflection, and sometimes I make the mistake. And what Reflector is it uses the AirPlay, Apple AirPlay, the same interface that used to send things from your device to your Apple TV, for example, or to your Macintosh. So here's my this is my real I'm touching it. I can't show you that, but you notice I'm not doing anything special with the mouse up here. I can move it around. It's all happening on the device, right? Okay. All right. And so then I'll go back to the IDE and we'll keep that same breakpoint. And now we're on the device connected through the Macintosh through the USB cable. And let's go and run with debugging. And then I'll switch back over to the Reflector. And what's going to happen is you'll see that, what was it, Project 15 will show up on my device here in a moment after it does the compile and link. And it also has to, again, deploy it through and do a code sign sandboxing and then send it through the PA server, through the Mac to my device. And there's Project 15, the icon showing up. And then we'll see the application come up. Now there's the splash screen, and you can have custom icons, custom splash screen. Those are just project options for the application that you can set. Here's my button. I'll click on the button. Okay. And then I'll go back to the IDE. I'm at the breakpoint, right? There's the breakpoint. So here's how it brings it home again. Debug, CPU windows. Those are not Intel instructions. Those are ARM processor instructions. Notice the difference.
Very cool.
So this is our compiler, our Delphi compiler for ARM, compiling inside the IDE, sending the app, code signing and sandboxing, sending the application through the PA server to my device, which is connected, and then back to, and then going back and forth. I heard that, whatever that sound was.
Apologies.
Oh, okay, great.
I'm trying to find a replay link, so that was my email popping up.
Oh, no problem. So this says it more than anything else. We go right from source code right to native code, optimized native code for the ARM processor, and the CPU viewer proves that it's happening. Now let's go. Oh wait, I have to come back here and hit run to continue the app, and then I go back, and there's 42 on my button, right? Okay. So that's the first part of native code.
It's 42 factorial. Is that what it says?
No, that's just 42 with it's a robust 42 answer
gotcha.
to everything in the universe. But you could do that if you want. That would be math, and we could do that. I think the great thing is with all of this, is you have full access to everything that's in the operating system. Again, you'll see in Anders' example here, and let's just kill the app. So we'll terminate it, and we don't care about that project. All right. The next one I want to do is I'm going to open up a C++ example. I just have to find it. Okay, let's do it this way. We'll go here. Let's go to C++ Builder, demos that we've been building. There's a location sensor demo. Let's open up the project, and let's sit here. So this application uses the T-location sensor component. This is the same component for FireMonkey that's available on C++, Windows, and Mac, Win32, Win64, and Mac. It's the same component that's available for Delphi, Win32, Win64, Mac, and iOS. Anders said there's a code snippet for that, so you can do the location sensor work. And when we activate the location, we're going to get the latitude and longitude. So let's go, and then we've got a button here to show the map. So in the case of desktop, we don't have a T-Web browser component yet for desktop. We have a T-Web browser component for iOS. And so what I'm going to do here is I'm simply going to say if I'm going to take the latitude and longitude that shows up in those two labels, and if the sensor checkbox is activated, meaning it is checked, then I'm going to have an if-def on Windows. I'm going to call shell exec using that URL, which is going to go to the Google Maps and pass the longitude and latitude. I can't say that well. And pop up Google Maps in the default browser, whatever is on each platform. And the same thing on Macintosh. I have an if-diff here. If the target is Mac OS, then I'm going to use the open command. I'm going to use the system function call, do an open to open the application. In this case, with a URL, it's going to open up whatever the default browser is. I think on my Mac, it's set. Well, I forget what I did. Maybe I made Chrome the default browser versus Safari on the Macintosh. We'll see what happens when it comes in. So let's run this on the Macintosh. So here I've got target platforms, Win32, Win64, and OS 10. Let's run this on the Mac. Again, it'll go through the PA server. So we'll compile and run it. Here's the C++ location sensor. That's that because I've got mirroring going on. But let's activate the location sensor. On the Macintosh, it tells me that I'm getting latitude and longitude, and I've got a T memo here where if the location sensor fires again on location change, and I think I have any change versus you can set an accuracy of distance change.
So where is that 37 negative 122 thing?
Well, I hope it's here in Scotts Valley. So let's click Show Map, and yeah, I have Google Chrome set as my default browser, and there we are, right here off Highway 17. We're right here in this corner. So that's how easy it is to build a multi-device C++ example that runs on Windows and Mac. And if you've got location enablement on the platform, then you can get the longitude and latitude, or you could make it an edit box and put a value in if you wanted. And then use the the operating system calls on each platform to display the location on Google Maps using the, I guess it uses geocoding when it sees that it's longitude and latitude as the parameters. That ampersand Q equals right here, right? Okay, one other thing, let's see. Oh, let's do a couple more examples real quick. Let's go and reopen a project. Let's do the CP effect. Here's an iOS application. I can do the same thing on Windows and Mac here in Delphi and C++ as well. We've got an image. This is just a T-image component. I've got a T-sepia effect component that's down here in the image effects. And there's a bunch of them, all sorts of, I don't know, there's 50 or so image and transition effects. You've got dissolves and magnifies and other things, and there's glow effects and monochrome effect and all sorts of things, sharpen effect. All of these are using the pixel shader capability in the GPU. Our desktop machines have GPUs in them, and these mobile devices, my iPad, my iPhone, my Android Nexus 7 tablet, they all have a GPU, sometimes more than one GPU, sometimes more than one processor core. So what I'm going to do is I've got the effect associated with the image, and I've got a track bar, and I have an event here called onTrackBarChange. The min and max value for track bar is 0 to 100, so I'm going to use that maximum and divide the current value to get a percentage, because the sepia, each of the effects has an amount of effect control from 0 to 1.0 or 0 to 100%. So we can run this on the device. So let's run it on the device, and let's switch back to Reflector. Let's get rid of this part and this part. Oh, did I turn off? Oh, maybe because I read well. Let's see if we get it to turn it back on and turn on mirroring. And there we go. So, okay, here it comes. And there's that CP effect icon. And it will start up here in a moment. And there we go. So here's the splash screen again. And now this same application that uses the same effects on Windows and Macintosh, the same GPU, as I slide the track bar, it does a percentage of sepia, right? So again, total control getting at the GPU, getting at the CPU that you've seen. These are some of the examples of native code. We're doing it all for you. You don't have to have some script library or make some operating system call. FireMonkey is wrapping not only device operations for 2D and 3D, but it's also getting at the GPU and the CPU with native code. Right? Okay, now I got one more. Let's see, one more thing. Okay, let's just do this last little bit real quick. And maybe this one you were going to do, Anders, I'm not sure, but I'll just do it quickly. Let's say File, New. And let's do a desktop application. And let's put a T-calendar edit. If I could type properly. So here's a calendar edit, right? And just run it on Windows. That's pretty straightforward. On Windows, it brings up, that look that you'd expect on a Windows machine, and the same thing on a Macintosh. Now let's say File, New, FireMonkey mobile application, blank application. Let's put a T-calendar edit. Okay, and let's go and run this on the device. Let's go and select the device. Okay, and switch back to Reflector. And we could test this on the simulator as well. So again, with Mac and Cloud, you can use the simulator. You can do a lot of work on the simulator. You can do even work in Win32 because we do our design in our Win32 IDE. So there's actually an option to bring up the Windows 32-bit version. So here comes, it's Project 16. I'm getting up there. It was Bob Ainsbury many years ago that said, you're a Delphi developer if you have either at least 100 Project 1.exes on your hard drive, or if you have project in triple digits. So I keep deleting them. So otherwise I would have been there a long time ago. So now when I select, notice now on iOS, I get the native date picker with this nice animation scrolling selector, and when we're done, hit done, and then we have the right date. And the same thing, oh, and I'm moving my device around. Okay. Same thing, if we go back to the ID one last time, we can actually do testing. We can go target platform, add platform Win32, and hit run here on Win32. And then again, you get the Windows look. So if you don't have a Macintosh, you can use quite a bit. Obviously, nothing that's device-specific related, but you can do a lot of work right inside your Windows ID. Then you can do iOS simulator work over on Mac and Cloud or on a friend if you have a friend that's got a Mac. That gives you the IP address, and if you're on the same system. So again, here's the simulator, and then you saw it over on the device. So those are some of the areas that I wanted to highlight. There are many, many more. You can look in the DocWiki on docwiki.embarcadero.com. There's a whole bunch of tutorials about doing multi-device and cross-platform application development, doing iOS development, and so on. You have full support for virtual keyboards. So here, if I put in an edit box, for example, not edit, sorry. If I put in an edit box, so a T-edit, then you can go over into the property editor, and you'll have keyboard type, and you'll see all the different keyboards. So again, the alphabet keyboard, the default keyboard, email address, VKT, URL, phone pad, and so on. Okay. So that's a lot about some of the things about true native. I showed you it's real native code. No emulation, no virtual machine, no bytecode, no setting it to some other language and then compiling it somewhere else. This is right from the IDE sitting here for both C++ and on Macintosh, and all those compilers are down here in Embarcadero, RAD Studio 11.0, bin. Somewhere in here, if I put DCC, we should get them. So config file, there's DCC32, DCC64.exe, DCC iOS32.exe, DCC iOS ARM, and then DCC OSX. So all the compilers are there for you, and the DLL versions of the compilers that the IDE loads on demand, depending on the project target. So you can look at all those. If you're doing build-based systems, make files and so on, automated builds, you have all the command line tools you need to build things.
All right, and so let's start here with master detail application for IB Lite. I'm going to go ahead and open a project that I had here. Okay, so this was the first internal attempt of doing a master detail. Of course, you wouldn't necessarily use grids. They're too small.
Except on my iPad with Retina display, then it was pretty
There you go,
big.
but you have to set the row height and all that kind of stuff,
sure.
right? But this is the traditional look and feel, if you will, of a desktop app. So here we just have a couple of different things. We have a data set. I'm sorry, a connection. We have a customer query. We have a sales query. Whoa.
Sorry, I found the replay of episode 1. But
oh,
anyway,
cool. Okay.
Go ahead. I'll put the link in, and then we'll figure out if it's got a playlist or not.
There you go. So like I said, we have a SQL connection, a customer query, and a sales query, and this is master detail setup. Then we have a customer data set provider, sales data set provider. We have a customer client data set and a sales client data set. These are all linked up through live bindings. So if I click on here and see the live bindings here, we can see how these are linked up. It changed the layout because I changed my resolution. But essentially, they're linked up to the two grids, and that's about it here. So if we go ahead and run this on the device, what it will look like is this. So here's my application. And you see at the top, we have the customer table. At the bottom, we have the sales table. I can click on a different entry here, and it switches. Of course, it enables a keyboard because I have editable data set. And you see that the detail records are changing as well.
It looks great, and if it was in landscape mode, it would look even better. Which
you mean like this?
Because I use layouts. I use layouts, and I oriented everything to the top and the client area and so on. So, yeah.
All right.
But again, it's not the preferred way. On iPhone, you wouldn't do it that way because you have the constrained amount of space.
Right. And there's actually only a couple lines in code here. There is the connection. We need to set up the connection to the actual location on the device, and in this case, it's in the Documents folder and Employee GDB there. The only other thing that we do is essentially open the connection and open the client datasets. And here on the customer client dataset before scroll event, we tell the sales DB bind source that we need to reset, so that it needs to resync, and that's what happens when I select another record. So let's go take a look at what this would look like if we were using list views instead.
And list view, maybe tell everybody, a list view is a new component that's not only available for iOS, but it's also available for Windows and Macintosh for both C++ and Delphi. And
it's specifically designed for high performance or long scrollable data bound lists.
Yeah. In fact, versus the list box, I mean, you could use a list box as well, but list box, is a full FireMonkey container where each list box item can have lots of things in it. Buttons, checkboxes, all sorts of stuff. So we created the list view so you could have this high performance and the look that is more native on the device when you look at an iPhone or an iOS device, an iPad, for example, right?
Yeah. So here this isn't finished by any means. I've just started this conversion. So here we have the customers. I just show the customer name, essentially, and then it's indicated on the right-hand side that there's more to it than that. So if we go to our tab control here, I have 2 items in my tab control. I can switch to the other tab control, which now has a back button. And notice it shows me the currently selected customer name at the top. If I then turn on the sales client data set, I will see the detail records as well. So there's my details. In this case, I've just linked up the total sales. I haven't customized it. I put a $sign and all this currency formatting on here. It's just a simple prototype here. And I have an action list. I have 2 actions that change the tab. One goes from tab item 1 to tab item 2 in a sliding fashion. And the other one, of course, goes from tab item 2 to tab item 1. So the second one is hooked up to this back button. And the first one is hooked up to my my event on the list box here. Or list view, I have an event called list view item 1 click, and I execute the change tab action 1. So that's essentially the only line of code that I added to this project to be able to slide between the 2 tabs. Okay, so if we go ahead and run this on the device, it will look like this. So here in portrait view, if I click and select, let's say Data Server International, for instance, it slides over and shows me the detail records for Data Server International. If I hit the back button, I go back to the customer table, I click on Geotech, and I see that they only have 1. I can click on something that has multiple ones. I think the first one has 5 on there. Yeah. And of course, I can drill into these if I wanted to. If I added more pages, I can slide to them back and forth. So that's and this also rotates if we want.
Yeah, so another example of that native look and feel, when you look at other mobile device apps and you see these kind of behaviors, the sliding, the master detailed pages versus master detailed database application. Again, this one, it's using the local version of IB Lite that has customer and sales tables inside of it.
Yeah, that's
but
correct.
You could easily hook into a multi-tier. You could have a data snap server built in Delphi or C++ builder, and then have a mobile client, a desktop client that would be very lightweight, where all the database operations of business logic is pushed on the server somewhere.
Yeah. And in fact, my IB license for IB Lite is deployed from my system to the InterBase license directory on the device.
And the database is
and the
too,
database right? Is employee GDB. It's right here. That is also deployed to the device. So everything is on the device, and IB Lite, of course, is a statically linked .a file linked into your
and it
app.
There's it gives you one transaction active at a time with IB Lite, and the database's limit is 100 megabytes of the database size. But if you want more, if you need bigger databases on the device, if you need encryption, lots of transactions, full support for InterBase, everything InterBase server, you simply use, you put in a license key for InterBase to go, which you can purchase. We give you a test deployment license. And so the nice thing is it's no change in the programming, no change in the files that you include, all other than put an IB to go license key or put an IB Lite license key in the deployment. And then you get the capability of either a full InterBase embedded in your application or InterBase Lite embedded in your application.
Yeah. So with that, I guess switch gears over to a simple example of an API that we don't wrap out of the box.
This is not rap music.
No, this is WRAP. And that's not a radio station either. So in this case, it's for setting or clearing the network activity indicator on iOS. So I blogged about this code a couple weeks ago. So I put that in here, and what we're doing is shared application is a class that's available to you in Objective-C, but also in Delphi this way. So shared application in this case. Of course, it looks somewhat ugly here because we have to wrap the UI application and get an instance from the actual Objective-C class and the reference to shared application. So that's what we're doing here. Then we call set network activity indicator visible, and we pass it, in this case, the opposite value of what it's already set to. There's a is network activity indicator visible on shared application that takes care of that for us, instead, as opposed to a get network activity, etc. So we can actually make this even simpler, but if we run this application on the device, it looks like this. I'm going to slide this down slightly. So when I toggle it, you'll see up here, you'll see the network indicator coming on. So there it is. Somebody's downloading something, somebody's uploading something, whatever it is. I click it again, and the network activity indicator goes off. So if I wanted to, I can actually make this simpler. I can do that, take this code out, and I can take this code out, and I say Apple utils here. And I have to add that. This is a demo unit created by David Clegg that is shipping as an example. So I can say add, and I'm going to navigate to Documents, RAD Studio, 11 samples, Delphi, RTL, cross-platform utilities. These are all the different things that Cleggy put in the product for us as demos. Apple utils.pass, and we're going to add that. It's going to say, okay, this is only for iOS, just so you know. And we hit yes. Okay, we want to do that. So here we have a bunch of different wrappers for different Objective-C classes. At the bottom, we see here shared application returns an NSA application, and it does exactly what we did in our code before, like this. Actually, on iOS, it does that. And this is for the Macintosh side. There's a active view. We can get the window handle of the platform and return the actual UI view on iOS, or NS view on Mac. We have an open URL, which simply opens a URL directly, and it calls another function in here that's this wrapper function for converting back and forth string to NS URL, which is a built-in type in Objective-C. Okay, so simply adding applet.utils here takes out all that wrapper code, and it still runs just fine. So if I run this on the device, the same thing will actually happen right here. So a very simple way of doing that. I'm going to skip the open URL example. The open URL example is actually above here as well in my blog. Just talks about this is what I had to do before. Luckily, David Clegg has an example that ships, and this is all you have to do here. So open URL, http, embarcadero.com or whatever. You don't even have to use shared application. He actually wraps open URL specifically as well.
Of course, for iOS Delphi, we have a T-Web browser component, right?
We do.
Maybe you showed that a couple of weeks ago, but there's a location example as a code snippet probably down there somewhere.
It's actually right here.
Oh, it's right there.
It's right here, the first one. So the iOS location, if I open that, we have a location sensor, just to complete David's demo here, I guess. It has a bunch of properties and an event here. Location sensor has a event called onLocationChanged. On location change, we simply take the latitude and longitude and display them in the user interface. We also fire off a Google Map URL in the web browser. And this is the web browser component sitting down here. This is designed for the iPhone, but let's go ahead and run it on my, I'm not going to run it on Simulator, I'm going to run it on the device. And let's go ahead and run that.
And again, our goal is to have a T-Web browser component that would be on all of our languages, on all the platforms we support. Right now, it takes advantage of the fact that there's a WebKit inside of iOS and there's a WebKit inside of Android that is an HTML rendering engine, a JavaScript engine, and I guess it does CSS stuff as well. And it came originally from the Firefox guys, right? From Mozilla World. I think that's where the WebKit.
Somebody told me as well, I haven't looked it up or anything, but somebody told me in Chicago also that Google forked WebKit, so they're now on their own essentially. Right?
Yeah, they needed to do some things to speed up, since Chrome OS uses WebKit for the operating system and user interface. Their blog said the reason they were forking it was to do performance enhancements and capability, so to help Chrome OS and the Chrome browser across platforms.
Okay. So here we turn on the location sensor. I get a warning saying, would you like the application to use your current location? And of course I do, otherwise I wouldn't get anything here.
And I would have gotten that on my Macintosh, but I had already said okay with the app that I had, and accept this as an app that you give permission to location. I could have gone and killed that, and it would have popped up on me as well.
There you go, and there's my location, roughly. We're actually, like David said, right about here.
Yep.
Okay, and then of course I can change the trigger distance and accuracy and all that kind of stuff here using the number boxes. If I click in here, on the device, not on the, I can change this here. Oops. Okay, let's go back and get back to where I was going to go, which was keyboard. You mentioned keyboards. Keyboards.
And also, I could have shown a demo. I've got a Delphi and C++ builder example for my Samsung Slate running Windows 8 that pops up virtual keyboards as well, because Windows 8 comes with virtual keyboard, and Apple has a virtual keyboard you can pop up if you need to but it'll actually launch. And there's a low-level platform services interface for testing to see if the device you're on or the platform you're on has virtual keyboard support. And FireMonkey takes advantage of that to know what it's running on so that you have access to whatever virtual keyboards there are, if there is a virtual keyboard.
Yep, and we'll see examples of that in this demo here. So the keyboard, let me just run it real fast. So here we have this application running on the iPad. If I click in the edit box, it's going to pop up the keyboard. Okay, so there's the standard keyboard, just characters, the alphabet. I can switch over to the numeric keyboard over here, etc. If I wanted to have a toolbar on the keyboard, I can, okay, so now I have a custom button there too and a done button. So when I hit the done button, it goes away. Edit. Search, you see what I'm doing. I'm putting in the Delphi menu here.
Yep.
So there you go, file edit, search, yep. and done. Now I can click the search button and it says, you pressed the button that says search. Or you press the one that says edit, or you press the one that says file. And done, of course, just dismisses the keyboard. So that's a very simple demo there.
And using a T-switch component, which on the device gives you a native look switch component. You can use the T-switch component on Windows and Mac as well, and it'll give you a switch.
Yep.
Yeah, so that's the T-switch component.
And that's it for my demos right now.
Yeah, which used to be, I think on earlier versions of iOS, it was rectangular with sort of blocky switch, right? And then they went to this kind of rounded thing. So again, the native types, native styles, native look on each platform.
Yeah, and I guess I should mention. Same component. I guess I should mention that this is actually a demo that does ship with the product. So if I open project and I go to my document folder, which is in 11 samples, and in this case, it's not in the iOS code snippets. It's in the FireMonkey mobile folder, and here we have the keyboard toolbar.
Yeah, lots of samples.
Right, and the other one, keyboard types, actually shows you numeric keyboard, regular keyboard, URL keyboard, phone keyboard, etc.
Okay.
And in this case, to just close the loop here on the platform services, so we grab the FireMonkey Virtual Keyboard Toolbar service in this case, and we set the toolbar and the done button to be on or off depending on what they're already set to. And when we click on it, of course, we switch that over. We add the buttons. Here's the
welcome everyone to. I'm sorry, I did that again. I apologize.
He's doing the replay again.
They're auto start. Sorry.
Oh, they're auto start. Okay. Did you post the link as a question? As an answer?
Did.
Okay, cool.
I posted the link. I just haven't found if there's a playlist. Sorry.
All right. So you want to switch back to the slides over there, and we'll close it.
Yep. Let's see. Organizer me. There's a couple Anders Olsons here now. So on my screen, and I think it should be on. Hopefully. I hope.
Yep.
Okay. There were a couple questions that came in. Someone was asking, can they use a list box to simulate a grid? And you can list box. You can do all sorts of things with list box. You can embed all sorts of controls. You can put a list box in an item of a list box. You can put buttons and bitmaps and strings and everything. So list box is this general purpose container. Usually we on devices we'll use a list box like as a group of settings. For example, some limited number. You wouldn't want to necessarily have a list box with 10,000 items in it. With lots of stuff on a device, it might take a long time to scroll and get through it. The list view is meant for that, and list view is populated using data binding or using the live bindings technology. A couple other questions about, let's see, can I use the camera to get a barcode? We have a T-camera component, and there's a code snippet for that, and that gives you a bitmap, and then you can use whatever logic or that you want to then take that bitmap and do something with it. Scan it for a barcode, a QBR code, or whatever it might be, do face recognition if it's a picture of people and so on. So all of that is available there. Let's just move this on really quick. Just a reminder, the conversation goes on all the time, so you can use hashtag EMBTDD all throughout the week and beyond, and follow Embarcadero Direct. People are putting notes up in the Twitter feed for all sorts of things, not just during these Developer Direct times. And again, a reminder of the email address, developerdirect.online@embarcadero.com. That gets to all of us. Okay, just summarize. True Native gives you great user experience, and you have full access to the hardware. It's all native code optimized for each processor, whether it's Intel processor or ARM processor. Next week, we're going to talk more about multi-device development, connecting into databases and business information services like web services, SOAP servers, and all of that. So lots of things going on there. And then on-device rapid prototyping, taking your application and scaling it up, doing multi-device data visualization. Anders has all sorts of cool engineering scientific graphics, and I'll be working on some data visualization of customer data and world data and things of that kind. And then we'll end it all on the 14th, bringing everything together that we talked about in this quarter of Developer Direct. Just a reminder that until May 22nd, there's a introductory discount, 10% discount on RAD Studio, Delphi, and C++ Builder XE3. Just go to RAD Offer on the Embarcadero.com site. And that is around for another, well, it's 12 days, I guess it is, yeah.
Somebody's asking, how does the notification service work? You can check out the iOS code snippets. They are actually in the trial as well. From the Start Here screen, the new Start Here screen for Delphi for iOS. There are a couple of different notification service examples, and there's a video that I recorded that as well. That's probably 45 to 90 seconds long.
Yeah. So both setting the badge notifications and then setting notifications either immediately or in the future.
Sending local notifications. If you want examples of push notifications, you can check out my blog. Luis Felipe Gonzalez created the server and client. I helped him out a little bit, and I showed that last Friday. So the replay, was the replay up now or no? We're still rendering.
Probably not up the episode 3. I have to.
We were both traveling, so yeah. They'll come online shortly.
What we might do is just rip out that part of it and put it somewhere.
True.
The push notification video sample you showed last Friday.
Yep.
I'll do that when I'm rendering it. I'll render the whole episode last week, and I'll pull out the push notification part into a separate little one.
I actually did. I shared it internally, so you can just grab that.
Oh, it's already okay. Great. Yep. Okay. Then let's see if we'll check for any other questions. There's some resources. There's Anders' blog, so blogs.embarcadero.com/AO. That's a great place to find Anders putting up all sorts of information about how to do things with iOS, how to do things with multi-device, and pointers to different places. And then Pavel and Steven and Sevalov are doing a whole bunch of blogs about multi-device and multi-tier and enterprise, and also mobile development as well. So you can find those things there. Here's our email addresses. So there's that one at the bottom, developerdirect.online@embarcadero.com, gets to the whole global evangelism staff and salespeople and so on that are following the conversation. And then specifically, here's Al and Anders at my email address. I'm going to get Al, needs a shorter one somehow too. You know, like just Al. Or show me the sizzle. Just show me the sizzle. That's for Al. He just always wants to show. It's great to have everybody here. So let's just... here's all the links to the product. Oh, sorry.
I'm surprised he didn't take It's All Good.
Yeah, no, It's All Good. He should have that one too. Where was that thing we wanted to put back up?
It was that one. I posted that as a response.
Okay,
a rapid prototype webinar. It's
So-
case sensitive.
Yeah, case sense because it's a short URL.
Yeah.
So capital R, P, and W. Again, that's... So next week, though, we'll... I did it. There. So next week, next Friday, every week through June 14th at 10 a.m. Pacific Daylight Time, whatever it is for you guys and gals. Next week is multi-device development from data to business information. So we'll see you all.
Seeing the date, you may have to do that one by yourself.
Why is that?
That is my 15th year anniversary.
What do you mean 15th year? Oh, here at the company?
No.
Wedding anniversary.
Yes.
Oh, yeah, that's a problem. Okay. I can do it because then I have to go to Cal Poly on May 31st for my meetings of twice a year meeting, computer science department. So maybe you can record something and we'll play it.
Yeah, probably.
Okay. Or we'll just do it. So again, let me get back to this stuff. That's how you can find us and get there. Thank you, everybody. We'll check to make sure we didn't get all the questions. Sorry, that we answered all the questions as opposed to not answering them. And everyone, again, thank you very much for being with us on Developer Direct. Sorry we ran over, but there's always so many great things to show with what you can do with Delphi and C++ and multi-device, not just for these mobile things, but for Windows and Mac desktops as well. We think of them all as devices now.
All right. Thank you all.
Okay, bye.